In this video, we're going to dive further into the application of palladium catalyst in various homogeneous catalysis, and in this part we're going to look specifically at a reaction called Heck reaction. And the goal of the Heck reaction, what is it? Is to make new alkene from existing alkenes. Like for example, we have a new alkene, which is what we have, let's say right here. What we'll have to do is to be able to make this particular alkene from an old alkene, which is what we have right here, and this will be done in the presence of a palladium catalyst. And the palladium we talked about on our previous video that is used in majority of homogeneous reactions is palladium 2. You can use palladium 0, but it would take an extra step, which is through a process called ligand migration, to be able to get to palladium 2, and most importantly the use of a specific organohalide or trifoliate to be able to generate the 16 electron type of palladium catalyst, which will represent as R2 bonding with X, where if you look at the conditions, we know that R, where we'll say R2, is either that of an aryl or vinyl or alkene. And all these guys, if you notice, they are actually unsaturated, and makes us to make a conclusion that we need these particular compounds to not have a beta hydrogen. And if we have a beta hydrogen on a sp3 carbon atom, then it means that we won't be able to execute various of the interesting process that is actually known in this particular Heck reaction. Now, another thing we need to take note of is that this alkene, which is what we have right here, must actually be a mono or di substituted. And what other conditions should we take note of? Next here is our X. X is either a halogen. Usually we go with bromide or iodide because they are actually reasonable living groups. Another better living group that is suggested is trifoliate, and trifoliate actually can be attached to any type of rings as long as it must have CF3SO3 minus. So this, when it leaves, is actually a good living group that will be able to facilitate various of the interesting last step reactions that involves reductive elimination. So the base that is also used can be a not so strong base, like for example we have triethylamine, and then we have sodium acetate, or we have sodium carbonate. All these bases can be used for this particular end reaction, which is called the reductive elimination. So now we've looked at the conditions and also identifying the various species that will be involved in generating a new alkene. Now let's dive into a skeletal catalytic circle, which is what we have at the bottom here. So what we notice is we have 4 steps right here. So the first step here is actually involving our organohalide, and this organohalide will just make our R to be R2. And what happens is that since this particular first metal complex is considered to have a 14 electron in this complex, this 14 electron complex is known to be really reactive. So what happens as a result is that our metal comes in and pick this R2 up, and then this leaving group comes in and then bonds with our metal center. So as a result, what we have is our R2, which is our R group, bonding with the metal, and the metal is bonding with X. This first step here is called the oxidative addition process, and then move to the second step. We actually have our alkene coming in, and what happens here is that once this particular pi bond coordinates with the metal, there is a reaction called a carbopalladation, which is a type of migratory insertion where this particular sigma bond, which is really reactive, you have to notice that really well, is actually going to be migrating over to this carbon right there, and then this pi bond forms a sigma bond with our palladium. So as a result of that, what we generate is this product. Once this particular reaction step is performed, which is called the carbopalladation, the next reaction step is where we need to involve our beta hydrogen. So what happens here is that this our beta hydrogen moves over to the palladium, and this bond cleaves and then forms our pi bond. And what happens is that we generate our product, which is our new alkene, where we have our R2 bonding with a double bond, and this is our R1, and our side product, which involves the metal coordinating with the hydrogen. Now once we have noticed our hydrogen and our good living group, what we do is we add our base. And what happens is that once our base is added, like for example, you can just use this base right here. What happens is the base picks up the hydrogen, the electron goes back to the metal, and this becomes a good living group. And what happens as a result is that we generate this with a charge on it, and then we have our good living group with a negative charge on it, and we regenerate our palladium, which is having a 14 electron in the overall complex. And if you notice, going from step 2 here to step 4 right here, we notice that all this palladium complex, they all have 16 electrons except for this top one right here, which has 14 electrons. That actually starts again with the new cycle. So you need to take note of these, and once you're able to take note of this catalytic cycle, you can be able to come up with a conclusion on what Heck reaction is all about. Heck reaction, in conclusion, begins with a 14 electron palladium complex. You perform your oxidative addition with our specific organohalide, and then once you're able to perform that, you identify the reactive sigma bond on that particular palladium complex that you generated after the oxidative addition. And once you're able to identify this palladium bonding with the R group, this bond is so reactive with a pi bond on your alkene coming in for you to perform a carbopalladation with your alkene. And once that is done, you actually perform your elimination of the new alkene by a process called beta hydride elimination, and finally regenerating our palladium 0, which has 14 electrons with the complex in the presence of a base. So that's about it for the key summary of a Heck reaction following a skeletal catalytic cycle and the conditions in here. And from this henceforth, we'll be able to apply this particular skeletal catalytic circle to other types of Heck reactions we'll be diving into on our future videos. All the same, stay smart and believe in yourselves.